Cambridge International GCSE Chemistry, Paper 2 Prep, tip number 3. Paper 2 questions about atomic structure mostly focus on the makeup of the nuclear atom and the subatomic particles that it's composed of, the idea of isotopes, and then the calculation or calculations involving relative atomic mass. You'll find these most often as question 2, question 3, or question 4. So the nuclear atomic model has it that all atoms are composed of 3 types of subatomic particle: the proton, the neutron, and the electron. I'm sure you're familiar. Most of the mass is in a small positive nucleus. The surrounding shells hold negative electrons. The nucleons are the particles in the nucleus. There are 2 types: protons, which are electrically positive with a relative mass of 1, and neutrons, which are electrically neutral, also having a relative mass of 1. The negative electrons in the shells have around about 1/2000th of the mass of a proton or neutron. Now, there are 2 numbers associated with each type of atom, the first of which is the atomic number, which counts the number of protons. So here we have 4 blue circles representing protons, so the atomic number would be 3. The second number is the mass or nucleon number, and this is the number of nucleons. In other words, the proton number plus the neutron number. We can deduce the numbers of electrons because the numbers of electrons in an atom is the same as the number of protons. So if we look at this diagram here, we have in the nucleus 7 nucleons. So the mass or nucleon number is 7. And we have 3 protons, 3 blue circles. So those protons are blue, 3 blue circles. So the atomic number is 3. So within this atom, we have 3 protons, 7 nucleons, and also we can deduce that we have 3 electrons. Paper 2 questions often ask you to interpret atomic number and mass number. So let's just do one example. Fluorine, atomic number 9, mass number 19. So the atomic number simply tells us the numbers of protons, which is 9. Well, the numbers of protons is the same as the number of electrons. So the numbers of electrons in the fluorine atom is also 9. But how do we work out the neutrons? Well, we know the total nucleon number is 19, but 9 of those nucleons are protons. So 19 minus 9, nucleons minus the number of protons, gives us 10 neutrons. So in the nucleus, we've got 10 neutrons and 9 protons, giving us a nucleon or mass number of 19. Isotopes are atoms of the same element which have different mass numbers. Another way of expressing the same idea is they're atoms having the same number of protons but different numbers of neutrons. So here are 2 isotopes. They are the same element, chlorine. They've got different mass numbers. They have the same number of protons but different numbers of neutrons. As we will see if we do this analysis, the protons is 17 for both isotopes. The neutrons, 18 for chlorine 35, 17 and 18 makes 35, and 20 for chlorine 37. 17 plus 20 gives us a nucleon number of 37. isotopes have the same electron configuration? Well, they have the same numbers of electrons. If they have the same numbers of protons, they have the same numbers of electrons. So therefore the same electron configuration, the same numbers of electrons in the outer shell, and therefore the same chemical reactions. A favourite question in paper 2. Calculations involving relative atomic mass are a favourite. This number is calculated by averaging isotopic masses. So to get an average, we want a true average which takes into account percentage abundance. Let's clarify by looking at an example. The two isotopes we looked on the previous slide, chlorine-35, chlorine-37. Well, we find in nature that the percentage of chlorine's atoms that are chlorine-35 is 75%. The remaining 25% have a mass number of 37. So we say the abundance of chlorine-35 is 75%. The abundance of chlorine-37 is 25%. So we need to take this into account in calculating the true average. So a question may ask, most simply, calculate the relative atomic mass for chlorine. Well, we do 35, the mass of the isotope, times the percentage abundance, plus 37 times the percentage abundance. Add them together, we have 100 items, so we divide by 100 to average. So taking 75 chlorine-35s and 25 chlorine-37s, our total numbers of items was 100. So that comes out as 35.5, and that is the number, the relative atomic mass, you will see in the periodic table for chlorine. So the formula, very simple. The relative atomic mass is the isotopic mass or isotope mass of the first, or isotope 1, times its percentage abundance, plus isotope mass 2 times the percentage abundance. The percentages must add up to 100, so divide by 100 to give you a true average. Now, if you look at examples in paper 2, you will see that there are 5 unknowns: relative atomic mass, isotope mass 1, percentage abundance 1, isotope mass 2, percentage abundance 2. So as long as you are given 4 pieces of data, for instance, the relative atomic mass, percentage abundance, isotope mass 2, percentage abundance, you can calculate the missing piece of data. So a lot of questions aren't simply calculate the relative atomic mass, but giving you the relative atomic mass and other pieces of data, calculate one of the missing items. Simply write out this formula with the unknown as x and calculate its value. So the advice doesn't change. Try some questions from paper 2. You'll find this topic at question 4 or 5. If you haven't got access to papers, simply Google Physics and Maths Tutor and you will find access to CIE papers there. If you found this helpful, please recommend the lesson to a friend. If you liked it, please like, and if you are so inclined, I'd welcome a subscription. Thank you very much.